back to this channel. In today's class, I want to explain the formation of differential equations. For any differential equation, the solution is of the form f of x, y, c subscript 1, c subscript 2, c subscript 3, till we get to c subscript n, where x and y are the variables, and c1, c subscript 2, c subscript 3, c subscript n are the arbitrary constants, or you can call them parameters because they can be varied. Okay, for example, if we have the y, the x equals 3x squared. This is an example of differential equation. And the solution to this one is what? Y is equal to what? X cubed plus c. So this is a parameter. So this parameter, another person can say that this y is equal to x cubed. So if you differentiate it, you are going to get what? 3x squared. Another person can say that this is y is equal to x cubed plus 1. Another person can say it is y is equal to x cubed plus 5, and so on. So all these functions, they are the family of these curve. They are the family of this function. So, and they have the same differential equation. So at times, you may be given the solution, the function, then you'll be asked to formulate the differential equation. So how do you do that? That is what I want to explain today. So there are some steps that must be followed if you want to form a differential equation when a function is given. Steps in formation of differential equations. Step 1. Differentiate the given function, that is the equation of family of curves, with respect to the independent variable, any independent variable present in the function, as the number of the arbitrary constants. So, for example, if you are given the function to be equal to y equals a exponential x. So this is a function. This is a function. This is the equation given to you, and you are asked to form a differential equation for this function. So the first thing that you need to note here is how many parameters do we have. So this is just one. This is the parameter. That is the constant, arbitrary constant. It's the same thing as parameter. So we have A is the only parameter present. So since A is the only parameter present here, we are going to differentiate it once. How many times? Once. So the number of the arbitrary constants determines how many times we are going to differentiate the given function. So since we have just a parameter, a constant, which is A, we are going to differentiate this one once, just once. So differentiate once. The y, the x equals a exponential x. So let's call it equation. Call this one equation 1. Call this one equation 2. So the next step, eliminate the constants. We want to eliminate we have just one constant here, which is A. So we want to eradicate it. We don't want any constant to be there. So how do we do that? We can say that from equation 1, from equation 1. We want to make A the subject of the formula. We have A equals what? Y divided by exponential x. Equation 3. So let's substitute equation 3 into equation 2. We have the y, the x equals, anywhere we see A, we're going to put y divided by exponential x. So we have y over exponential x multiplied by exponential x. So exponential x cancel exponential x. So now, the last step, after the elimination of the constants, the remaining equation is the required differential equation. So the required differential equation from this one will now be the y dx equals y. So that's just what they asked you to do. And recall that the y dx is the same thing as y prime is equal to y. So this implies that y prime minus y is equal to 0. So that is your required differential equation. So this is the required differential equation. So you have to note how many constants do you have. If you have one constant, it is going to be differentiated once. If you have two constants, you are going to differentiate it twice. If you have three constants, you are going to differentiate it twice, and so on and so forth. So here is another example. Y is equal to A sine 2x plus B equals 2x. So the first thing that you have to note here is the number of constants, that is the parameters. How many parameters is in the function? So we have two parameters. Two parameters, A and B. So since we have two parameters, we are going to do what? Differentiate twice. So differentiate twice. So you are going to differentiate it twice. Differentiating implicitly and chain rule with respect to x gives, so differentiate twice gives 1 multiplied by dy dx. So we have dy dx equals a, then if you differentiate sine, it gives what? Cos, then 2x, differentiate it, you have what? 2 plus b. Differentiate cos gives minus sine, then the 2x. Differentiate the 2x gives what? 2. So dy dx equals 2a cos 2x, then minus 2b sine 2x. That is the first differentiation. So differentiating it again, so we want to differentiate this one. Since we want to differentiate twice, we have differentiated it. This is the first differentiation. So the second one now will now be, if we differentiate this one, it's going to give us what? The squared y dx squared equals, so we have 2a, that is constant. If we differentiate cos, it gives what? Minus sine, then 2x. Differentiate 2x gives what? 2. Then minus 2b. Differentiate sine gives what? Cos. Then 2x. Differentiate 2x gives 2. So the squared y dx squared is equal to, so we have minus 4a sine 2x, then minus 4b cos 2x. Look at this right hand side, you can see that they have -4 in common, so let's factorize -4 out. We have this squared y dx squared equals -4 into brackets a sine 2x, then plus b cos 2x. So let's look up. Let's call this one equation 1, the first differentiation equation 2. So let's call this one equation 3. So if you look at this a sine 2x plus b cos 2x, you can see that it's the same thing with the equation 1. So now substituting equation 1 into equation 3 gives the following. So the squared y dx squared equals -4y. So, and the last step said that after the elimination of all the constants, the remaining equation is the required differential equation. So the required differential equation is what? D squared y dx squared plus 4y equals 0. Or you can write it as or y prime prime plus 4y equals 0. So that is the required differential equation. So you have to follow those 3 steps when you are given any function. So determine the number of parameters given to you, because that will let you know how many times you are going to differentiate the function. So after doing that, you have to eliminate the constants. So after elimination, the elimination of a constant, the remaining differential equation is the required differential equation. So till I see you